Let's take a look at this balloonist problem. A hot air balloonist rising vertically with a constant velocity of magnitude 5 meters per second releases a sandbag at the instant when the balloon is 40 meters above the ground. After it is released, the sandbag is in free fall. Compute the position and velocity of the sandbag at 0.25 seconds and 1 second after release. Okay, so we want to find what is the speed and what is the position. Okay, so we know that initially the sandbag is 40 meters high, and we want to go ahead and find that position. We know the initial velocity is 5 meters per second, and because it was up, I'm going to make that positive. The acceleration, it's in free fall, so negative 9.8 meters per second squared. Now they want me to find this for both 0.25 seconds and 1 second. I'm going to go ahead and we'll show it for both, I guess. So we got to go 0.25 seconds, and we also have to do it for 1 second. So we're just going to do the same calculation twice is what we're going to end up doing here. So to find the height, I'm going to pick an equation without v final. So y is equal to 40 plus 5 times our time. I'm just going to put t in here for now, plus 1/2 times negative 9.8 t squared. And so I find out that my y at 0.25 seconds and my y at 1 second are, the height was 40.94 meters, and the other one was 40.1 meters. Okay, so what that tells me is that it went up and then it's on its way back down. So somewhere, or maybe before this, it reached its maximum height, because as it's released, it's going up, it goes up a little bit and then falls back down. So how do I know if this 0.25 seconds is on the way up, and meaning the maximum height is somewhere between those two, or it's on the way back down and the max height was before it? How would I know that? And that's where they want us to go ahead and find the final velocity. And so I say, okay, well, v is equal to 5 plus negative 9.8 times t. And so I plug my values in here. I didn't quite type these in quick. I can do that though. 5 minus 9.8 divided by 4 gives me 2.55, and it is positive. That means that it is on the way up at this point, at 0.25 seconds. And then the velocity at 1 second is going to be negative 4.8 meters per second. And so it's on the way back down, meaning that if I was to put those 2 points on here, I would say, okay, one of them must be here, one of them must be there. All right, part B. How many seconds after it's released does the bag strike the ground, and with what velocity does it do that? Okay, so now because I'm going between different points, I need to make another list of variables. So again, we're still starting at 40 meters high. We're reaching the ground. Now, when they say strikes the ground, they're talking about the instant before it hits the ground. Initially, it's traveling at 5 meters per second up. The acceleration is negative 9.8 meters per second squared for that sandbag. And I want to find the time. Now, I also want to find v. Okay, so there's 2 ways that we can go about doing this. Because if I try to solve it in the order they want me to, they say, okay, solve for t. I don't know v final. So I pick the equation that doesn't have v final. I get y is equal to y naught plus v naught t plus 1/2 at squared. And I get 0 is equal to 40 plus 5t minus half of negative 9.8, 4.9 t squared. You see we have a quadratic. And so I'm going to go ahead and show us how to put that into Solver. So let's do that right now. All right, we're going to have to go ahead and use Polysimul 2 to do this polynomial for us. So we're going to hit Apps. If you have a big list, you are going to be scrolling down to Polysimul 2. If you just want to hit alpha and then the letter P, because it starts with the letter P, it'll kind of shorten that list for you. Otherwise, you can delete some of those. So I'm going to go ahead and take Polysimul 2. I want to use the polynomial root finder. I want a second order. I'm definitely going to want a decimal answer. Auto, sometimes it'll give you fractions. I really just want real decimals. We're going to keep it in degree mode because we're going to be using degree mode. In order to hit this next button down here, you're going to have to hit the graph button that's directly below it on your calculator. And here's where you're going to put in the information for your equation. So next to the t squared, I have a negative 4.9, so I'll put negative 4.9 in there. Notice they have a plus minus. If you're using an older calculator, it'll just want these bigger gray boxes. Here I have to have a plus, so I'm going to do plus, enter 5, enter. It's kind of a little slower in my opinion, but that's what they wanted to do. So notice I have 40 down here, but I haven't hit enter yet. It still has 2.6 up here. So in order for it to register what's in that box, you do have to hit enter. Now we're going to go ahead and hit solve. It will give us all the solutions to this problem. So hitting that graph button again, it will solve. And so we end up with 2 times the negative 2.4 seconds and the 3.4 seconds. We, of course, want the positive time, the 3.4. So back to the board. All right, so we see we got a time of 3.4 seconds. Again, we wanted the positive time, so if you were getting that negative time, make sure you put in a better guess. So we got 3.4 seconds. Now, to find the final velocity, I can just go ahead and say, oh, well, v is equal to 5 minus 9.8, or plus a negative 9.8, however you want to think about it, times 3.4, and I get a final speed of negative 28.44 meters per second. Now, if you wanted to find the final velocity first, and you're like, oh, I could just use v squared equals v naught squared plus 2a y minus y naught. I know the initial velocity, I know the acceleration, I know both the initial and final heights. I could solve for v final. The one thing to remember here is that plus minus on that square root. You need to use the negative sign so that when you plug that value in here, you'll get the correct time. That's probably the only thing to be careful of when you do that. But those are our 2 values there. And then part D. Part D wants to know what is the greatest height above the ground it reaches. So what is the maximum height? I know it's somewhere bigger than my 40.94, but what is it? How do I find it? And so there is a condition that we know. So we're going to go negative 9.8 because it's in free fall. It starts at 5 meters per second. Starts at 40 meters. I want to find the maximum height. Now, when you throw something up, when it reaches its maximum height, it switches directions of motion, goes from a positive velocity to a negative velocity. When it does that, the only way to go from positive numbers to negative numbers is always to go through 0. So that means that when we reach a maximum height, this is 0 meters per second. So now I can go ahead, pick an equation without time. So I have v squared equals v naught squared plus 2ay minus y naught. And I'm solving for y. Okay, so I have negative 5 squared divided by 2 times negative 9.8. So I'm dividing the 2a over, is equal to y minus y naught. So I got to add the y naught over. So plus 40 will tell me that maximum height. And so the maximum height it does reach is 41.28 meters. And lastly, part E wants me to sketch some motion graphs here. So for our velocity, or our acceleration versus time, the acceleration is constant, so it's always this negative 9.8 meters per second squared, just a line like that. Our velocity graph, it starts out at a positive 5 meters per second, and it falls sometime in between like 1 second and 0.25 seconds. It crosses that line and it hits the ground over here, moving at a speed of negative 28.4 meters per second at a time of, and I'm getting these numbers right here, 3.4 seconds. Now my position graph, so it starts at 40 meters here, rises up and comes back down. It does reach a maximum value here of 41.28. It does reach the ground at that 3.4 seconds. So again, when we sketch a graph, we want to make sure we're including points that we know. I did not find the time for max height, but if I did know that, I would go ahead and mark that off as well. That would also tell me what point it crossed that axis at. There's that example.